Welcome, everybody. Thanks for joining the last session before, I believe, drinks and food. So hopefully we'll make sure we end on time. My name's Stephen Gatchell. I'm a partner and head of data strategy for a company called Ortecha. We are a boutique consulting firm based out of London. We do have a booth here as you go into your drinks tonight. We're right next to the drinks, so please pop by, say hello. I'm joined by Matt. Matt, want to give a quick intro?
Here we go. Thanks, Stephen. Matt McQueen, principal consultant with Ortecha as well. I'm based out of Nashville, Tennessee, so I'm happy to be up here in Boston. My good friends here drugged me out to Fenway Park last night, so bear with me. It's been a long day.
We sat on the Green Monster. It was pretty cool. So shout out to our partners at RDoc. Thank you. So look, today we're going to talk about swarm intelligence. I see some familiar faces from the last session where we really got into what is swarm intelligence, and we talked about the impact on enterprises and so forth and how jobs can change. And there was a lot of great engagement from the audience. So definitely encourage that. If you want to ask questions, please do so. Just wait for the mic because there's people online and they want to make sure we get your questions online as well. And so we're going to talk today really about swarm intelligence. So if you think about swarm intelligence, the way I look at it is it's really multiple agents that resonate and coordinate and act together, right? On an enterprise data, it promises speed and scale and execution. So what does that mean? You create a bunch of agents, you put them together, we call it swarm intelligence, right? And so we're going to talk about that today, not only from a few different slides, but we're going to actually try and do a live demo, which we weren't supposed to do, but we're going to do that anyway. One other thing, for those of you that did answer the poll online, really appreciate that. And just for those of you that may not have seen it, we asked basically, what is the best business language to use related to understanding ontology and semantic products? So for those of you that may not understand any of those words like ontology and semantic products, we are a data conference, so most of you probably know what that means. But that's one of the things that we try and work with customers on to really help with the accuracy of AI, right? If you maintain your data and you build ontologies, we're going to talk about knowledge graphs a little bit today as well to understand how you improve the AI. The poll results. I was a little surprised about this. The first one, 6 out of 41 people said increase the accuracy of AI responses. The second was understand how your business communicates across functions, 15 out of 41. And the winner was ensure the correct data is used in the correct context. So for those of you that are trying to implement AI at speed and scale, context is a huge conversations. We're going to talk about some of that today. Next slide. Is that it? Good. Nope, I already did this one.
That's all you got.
Okay. Now I'm going to turn it over to Matt. I'm going to go hang out. If you have a question, just raise your hand and I'll run over to you so that we can hear you on the mic, okay?
All right. Thank you, Stephen. So swarm intelligence, multiple AI agents that reason, coordinate, and act together on enterprise data. It promises speed, scale, and execution, but only if AI can act on data that is structured, governed, and true to how the business works. So that last part is what we're going to focus on today. How do we make our data available to AI in a way that's true to the business and not just averages that AI can find on the internet? So I'm going to ground this with a quote to start off with. When intelligence becomes cheap, meaning becomes everything. So you may know Tony Seal. If you don't, look him up on LinkedIn. He's a good friend of ours at Ortecha. Everything we're talking about here is really grounded here. Meaning becomes everything because we can all access the same frontier AI, LLM chatbots. And so that intelligence is at our fingertips, right? In the last session, if you joined us, one of a reoccurring talking point was on how, what used to take weeks or months to do can now be done in a fraction of a second with a simple prompt. We could write code faster than ever before. So that intelligence is cheap. We all have access to that now. It's really incredible. What we now need to focus on is the meaning that makes our data unique to us. So without true business context, your AI is just detecting statistical patterns. We know how this works, right? AI, generative AI, LLMs are predicting the next best word in the sentence, and that's great when we're looking for when we're doing research, right? It's great when we're looking across corpuses of public information, but it doesn't always work when we need validated, auditable answers. And so what we get are flawed recommendations, biased outcomes, and ultimately misaligned decisions. When this is scaled across your entire organization, every employee, this is happening today, right? Everybody has access to some AI model, whether it's Copilot or ChatGPT or Claude, et cetera. When that's scaled across your organization, you end up with all of these what I would call EUCs, these end user computing applications that we don't have governance or control over, and we don't have trust. At least we shouldn't have trust in the outputs that we're getting from them. We may have trust in the people that are using them, but in the spirit of the concept here, swarm intelligence, we want to shift that trust to the AI. So I'm a data management consultant. That's what we do at Ortecha. I work with clients over the past about 10 years now on standing up data management programs. And now I'm here today saying we need to move beyond managing data. We need to start architecting knowledge. If you heard Juan Cicada's talk just earlier across the hall, one of his talking points was, are you a knowledge architect? I think he said engineer, a knowledge engineer, right? It's the same concept. We're applying the data management foundations in a new way to now generate a structured set of knowledge that's not just answering what the data says, but how can we use that data? What does the data mean in context? So why is this so important today? Because AI is converging. There's some studies out there, and if you'd like to get deeper on this, come by the booth and we'll pull up some citations, some really interesting papers on this. But actually, I'm getting ahead of myself, so let me talk to this slide. Your competitive advantage is dissolving, right? So what is your competitive advantage in your business, and how is it different from a company that may do something similar or the same as you that's just down the street, right? When you're all using the same AI models, you may be asking the same questions and getting the same answer as your competitor down the street. That's what we need to solve today. So your competitive advantage is currently invisible to the AI that you're asking and that you're introducing into your organizations. So it disappears the moment that AI can't see what makes your business unique. What is unique, it's your rules, your definitions, your people, how your people are organized and structured, how teams do different things across the business, and ultimately the business process making decisions, right? This is oftentimes locked in people's heads. It's written down on paper, put up on a shelf in your strategies, your SOPs, process diagrams, and so forth. Based on working with many clients over the past several years, this documentation is not in any machine readable format. And yes, we can give those documents to a Copilot, and it can consume those documents and answer questions on those documents. But the question is, can we really trust it to act and to remember that knowledge and leverage that knowledge when we deploy it in an agentic fashion and trust it to go make decisions on our behalf across the organization? So now, why is this more important than ever? Because AI is converging. So there are studies out there that show testing various different frontier large language models and asking them the same questions. I think the example asked, give me a metaphor for time. And if you think about that, If you're creative, you should be able to come up with an almost endless number of answers, right? A metaphor for time could be anything. But those frontier models across Anthropic and OpenAI and Microsoft, they all 9 times out of 10 came back to the same metaphor. Time is a river. So is that the kind of intelligence that we want in our organization? Is that going to support our competitive advantage and what makes us unique? I don't think so. It's what every organization, it's the same answer that every organization is getting. So the models are becoming interchangeable, they're becoming commoditized, and they're increasingly homogenized. So we want to introduce AI, adopt AI into our workforce, but in a bespoke way that understands our company and the ways that we work. And I'll use another example. Think about onboarding a new employee. You wouldn't just, hopefully, you wouldn't just tell them, go read my website and come to work tomorrow, right? There's typically a much longer, more in-depth onboarding process, which involves training materials. It involves interviews or meetings with their coworkers and their peers where they're learning all of this knowledge that's written down somewhere, curated for them in training materials, and most importantly, locked away in people's heads. So how do we fix this? It's not about just creating more data. You all have enough data, I hope. It's about building knowledge in a way that AI can leverage that information. And by doing so, we're going to increase our human experience as well. So semantic data product is what we're building. And I'll say, as I work with clients building out foundational data management programs, this has changed. This concept has changed the way I deliver all of my work. I'm no longer just delivering a PowerPoint presentation, right, of an operating model or a RACI or a data management process inventory. I'm also delivering that information in a semi-structured or a structured format that can, whether or not they are ready for it, whether or not they're at the maturity level yet, can be deployed for AI to consume that information and refer back to it consistently for reasoning when they deploy AI to ask questions about what regulations apply to this data set, or I'm a data steward. What's my role? What processes in the program apply to me, for example? So we're building connected, explicit, and governed semantic data products. So if we zoom out, over the past 20 plus years, data architecture has done one thing really well. It asks, what does the data say? And it can answer that question. We build out our data lakes. We build data products. As a result of that, we stand up dashboards and applications that tell us about the past, that look at that data and tell us what that data says. AI needs us to answer a different question, and that is, what does the data mean? What is a customer, right? The classic example, a customer means something different to your sales department, to your support department, and across different divisions of your company. So harnessing that knowledge, harnessing the context, not just the definition, but how it relates to other information and the other parameters around a customer, right? So what I'm describing is obviously a semantic layer. So that's what this knowledge architecture shift contains. It's the same data layer at the bottom, and that's what honestly makes this easy, is that we don't have to change your underlying data structures. There's a pathway to iteratively build a semantic layer or a knowledge layer on top of your existing data that allows us to drive intelligence through AI, augmented decisions, data products, contextual insights, and advanced predictive analytics. So moving on from here, it's answering the question of what does the data mean, right? So if we zoom back in, how do we build that? We just saw what the architecture shift looks like. How do we drive machine readable understanding? What is the semantic layer or the knowledge layer made up of? And the answer there is expressiveness. So this is the ladder of increasing expressiveness. And I'll just walk you through this quickly. So at the bottom is a list. We have tons of lists. I have tons of lists. I bet everybody has a list of many things throughout their life and in the business. Add a definition to those terms in your list and you have a glossary. The glossary is a great tool for human consumption. And most organizations stop here. Do your traditional data catalogs, or how's your glossary? They have great value there, but to really enable AI, we need to increase the expressiveness. So the next step is to put some structure to that glossary, which turns it into a taxonomy. So this adds the parent-child relationship and a category over those glossary terms. So we have a little bit of relationship going on in a taxonomy. Where the real magic happens is by defining explicit relationships between terms and adding my little asterisk down there is not just the relationships, but the rules and constraints that dictate when a term means something, what shape that piece of information must be presented in, for example. So that ontology is now your semantic layer that defines everything about your data. Knowledge graph at the top of this pyramid is creating the connection between the ontology, the shape of the data or the schema, and the actual data sources. So now we have a true knowledge graph that understands the shape of the data in the ontology and how it's connected to your existing underlying data sources. So a fun quote here: knowledge is knowing that a tomato is a fruit, but wisdom is not putting a tomato in a fruit salad, right? So the taxonomy is what's going to give you that information about how do I classify a tomato, but it's not until the ontology that you get the wisdom about how do we use a tomato. Where can my chef put that in a dish that I'm going to be happy with?
Is the tomato really a fruit?
I believe it is. Yeah. If you learn one thing, that's what it is.
Like ketchup is a fruit smoothie.
Okay, so I'm going to walk us through. I made a deal with the AV team to let me control the computer here. So I'm going to attempt to show you what this looks like. I'm going to use a couple of tools here. It's very simple. I just want to give you a sense of how easy this can be, and just talking about it and saying what an ontology is usually not enough. So I'm going to show you the T box, which is the terminology box, and this is the ontology. This is where we define the core concepts, and we put in our definitions. We define the relationships and the constraints. And then we'll talk about the transformation model for purposes of simplicity here. The key is there are tools out there that make this really easy to connect to an existing CSV file or Excel file or a SQL database, right? And actually just drag and drop column to class in my ontology. And then finally, the A box is what is the result of that. That's the assertion box, where we've actually created the knowledge graph and tied the ontology class to the underlying data. Okay, So give me a second. I'm going to switch out my screens. I may regret that, but no, I'm okay.
And while Matt's bringing this up, I think the key here is we are focused on the process and the concepts, not necessarily the tools. So even though you'll see some tools today, it doesn't mean that you have to use these same tools. It's just what we're doing for the purpose of showing you the concept.
That's right. So yes, this is a tool called graph.build. It's a very simple way to build an ontology and start modeling. It's very similar to a whiteboard. The important part is, if you can capture this information anywhere. You can capture this information on a whiteboard. Sorry. Okay. But if you capture it in a tool like this, you're actually drawing the data model in real time. And it's very easy to iterate on this. So what are we seeing here? This is an ontology that we've pre-built around a banking customer or client, as it's called here. So the client, as you see in this middle node, is related to several other classes. So we've defined that client. We've defined incoming third-party data that we've collected against our set of customers. We've defined the customer credit score. And then we've defined a class for their marketing consent. So what information are we allowed to use or distribute out to that client? Additionally, we have the household. So are they a member of a household? So I'll just focus on that one because it's right in the middle. So client has a definition, a natural person who is a customer of the organization, right? And this is leveraging schema.org. So I just point that out. Ontologies, there are tons of open source ontologies. Schema.org is one that's a massive ontology published by Google, and it's used in the Google search engine. So we're able to leverage that information on a client, use case by use case. Do I need to define my own client? Or can I leverage an industry standard to do that? So pulling in existing published ontologies is always something to look for, but it's never something that we try to do in wholesale, right? And then a member of a household. So this member of is a relationship line. So client, member of household, that's a RDF triple. Client is the subject, member of is the predicate, and household is the object. So that's the pattern you see throughout here. And then on the other side of this ontology, we have the product, the banking product. So a customer has bought a product, and we have a class to define that product and various characteristics about that product. And importantly, at the bottom is the eligibility criteria. And so that's what I'm going to focus on as we ask some questions of this graph. Can we create a reasoning engine here to say, based on the known information about a client, and the known information about a product, let's ask it some marketing questions. What are my popular products? What clients would be likely to buy a product, and so forth. Now, this is the simple view. This is just the classes of the ontology, and I can expand this now. And obviously, I've already populated this because I didn't want to bore you with drawing all of this out. So we can expand this to the properties associated with the classes. So what attributes do I have on a client? So we can see a social security number, an age, employment status, name, etc. And then if we look down towards the bottom at the eligibility criteria, we can see things like minimum and maximum age, must have a social security, minimum, maximum income, these types of things. So from here, we have an ontology, and you can imagine getting in a room with your subject matter experts and hashing this out in real time. This is something that we do with our clients, and it's an incredibly valuable use of time to just whiteboard this, but instead of whiteboarding, we're actually generating an ontology. So everything that's modeled there is automatically represented in RDF triples. So this ontology downloaded and or through a workflow, brought over into your data catalog, into your marketplace, that then you can start querying this ontology just like the rest of your data products. So I'm going to move to that view now. So again, this is just Ortecha's innovation lab. We've kind of stood up this user interface just to exemplify a data product marketplace, if you will, but just showing some of the capabilities here. So I've connected that ontology, and I've connected the underlying data. Sorry, I skipped over a talking point here. That ontology, I gave it to ChatGPT and said, create a synthetic set of data that fits this ontology. And now I can start testing that ontology, right? So it's an iterative development process that's very quick. With synthetic data, before I go into production, I can say, can I ask this ontology the questions that the business needs answered? So one of the things this does, we can ask AI to define or describe the ontology. So if you were in a data catalog or a marketplace and you discovered, hey, I have a marketing data product, right? Or a customer data product. Well, that ontology already contains all of the information that AI needs to accurately describe what it is. And if we scroll down to the bottom, we've instructed this prompt to say, tell me some questions that this ontology should be able to answer. So customer eligibility, marketing compliance, product performance, and so forth. So some questions we probably didn't even think of when we started out modeling this concept. Now we can give it to AI and say, look what we've done. Now how can we use it, right? So at the beginning I said, I want to build a model to address product eligibility or customer eligibility, but look at all these other things that I just solved the problem for. So let's ask it some questions. I'm going to ask, now you have to bear with me. So I'm going to ask it.
Now you want me to hold the mic, don't you?
Probably, yeah. What are the most popular products?
At least I'm useful for something.
You can narrate too. Oh. Sorry. Never good to see the news. Okay, so what are the most popular products? Thanks, Stephen. So we see the result here. Hang on. So I'll find the most popular products by counting how many contracts or purchases each product has and ranking them by popularity. So we get a tabular response here. And by the way, it doesn't have to be tabular. We can use the power of generative AI to give us a creative answer, right? But we want to see the data. We want to demonstrate that the data that AI is giving us is actually pulling auditable values from our underlying data set by understanding the knowledge graph to interpret the question that we answered. So we see a product label and we see a count, and it has structured that by popularity, right? How is it doing this, right? You may be familiar with this, but it's doing this by generating a Sparkle query to query the graph. So Sparkle is a graph querying language, and it so happens with all the documentation out there that large language models are really proficient at writing Sparkle queries. So this is what it looks like, right? And if we're happy with the answer that we got, if we validated it, the human review cycle, this query becomes a product of itself, right? And this is a really simple query, but imagine this was much more complex. This query is a product. We could save that as a query that we can rerun and continuously get the same updated results. So we let generative AI write this Sparkle query, and it's interesting to read it, not the code, but the descriptions to see its thought process. So let's ask it a slightly more complicated question.
And Matt, while you typing that, I will say, you touched upon generating synthetic data. I think one of the challenges that we find in most organizations is the security aspect and the privacy aspect of people's data, right? Mm. But if you can take a knowledge graph like this and then generate synthetic data, there is no risk from that perspective on the security side. So it gives you that capability to go in and test that ontology without having personal information and IP information and sensitive data in general. So I think it's an amazing thing to do from a testing perspective before you put it into production.
Yeah. So what should I recommend next? Now we're asking AI to be a little bit more creative, right? Don't just list out the data, but tell me, of course, the demo can't answer my question.
It did work like an hour ago.
It worked a second ago.
Yeah, it's not a video. This is a real live demo.
Let's try the next one. So I would, going through increasing complexity, what should I recommend next? And then the next train of thought is, who should I recommend a product to? So we would have seen a list of products, and what should I recommend next? One of the products in our ontology, in our graph, is a savings amplifier account. Okay, savings account. So let's try this one out. We're thinking about it.
So it couldn't answer the less complex one, but we're hoping it's going to answer the more complex one. Okay.
And it'll prove me wrong, I'm sure. But it is an interesting. There we go. Look at that. It's an interesting fact. The more complex the query, the less likely it is that you'll have a wrong response. Because the more complex it is, it'll write the Sparkle query, and it may get the Sparkle code wrong, but that's going to result in no answer. So it's a very low chance that you would receive an answer and that answer be wrong. There's a fair chance that AI gets the Sparkle language wrong, but that means you're not getting a wrong answer. So this is interesting. It actually looks even better than when I tested it. So we get a list of customers and a reason. If I can scroll over there. So who should I recommend the savings amplifier account to? Rebecca Turner, number 0. She's an eligible customer with excellent credit score, a high income, her age fits the eligibility criteria, and we have that data populated right there. So let's take a look at the Sparkle query that it generated. And we can see the thought process. So find the account product, get eligibility criteria. And in purple there, you can see those are the unique identifiers that we defined in our graph. Find customers who haven't bought this product yet. I didn't tell it to do that, but that's a good idea. Check they haven't already bought. Get customer details for eligibility checking. Get eligibility requirements. Check those conditions. Then generate recommendations. Generate reason based on customer profile. So again, I didn't even tell it to give me a reason, but that's the power of generative AI, that it guesses what you really want. And here you can see it's not just giving me a probabilistic answer, but to inform that answer, it's actually running a deterministic query. And you can see the math. So it's invented a recommendation engine here, and we can validate this engine and then adopt that into our business process. Question.
Wait, Mike.
I think you asked AI why in your query. So you did ask for
Oh,
giving it a reason.
good catch. Good catch. Yes.
One of the other things I think I really like about this is when you ask the why, there's defensibility is one, and also understanding not something is not a black box, right? You can go back and say the reason why this person was recommended for this product, here's all the reasons why, and actually validate that, right? So you have an evidence-based reasoning behind it, which is super helpful, obviously, in regulatory environments as well.
How is that different?
No, you gotta wait.
How is that different than explainability?
So explainability can be subjective, quite honestly. Like you go through and have an explainability of how a model was created as an example. This is evidence-based. It's actually showing you the detail of how it came to the decision making, which to me is different.
Okay, cool. Let me go back. I'll wrap up with a perfect couple of slides. So we saw the ontology, I talked about the iterative process of creating synthetic data to test the ontology. What I should have said, if we got an answer, or if we asked an answer that the AI could not answer, first off, that's a success. If AI is telling me you don't have the data to answer this question, that's a hell of a lot better than it creating a response based on fictitious or internet-based data. We did see some answers. We talked about the transformation model, where there's great tools out there that you can go and connect the ontology to your existing underlying data sources. If you want to see more about that, I'm happy to come see us at our booth after this or tomorrow. We can take a look at more of this. So what is this concept that we just demonstrated? It has a name, Neuro-symbolic AI. So this is leveraging the generative AI probabilistic large learning models, the creativity that allows us to interact, for AI to understand our natural language, and then give us a result that we actually want to see, that's tailored to us, right? And then pair that with symbolic AI. And symbolic deterministic AI, this has been around forever. It's now coming back into play because of the ease at which we can combine these two technologies. So symbolic AI is what we saw with the ontology and the graph. It's deterministic reasoning, rule-based. It's explainable, observable, and far more governable than generative AI. Why does this matter for the enterprise? Faster AI deployment, fewer hallucinations. It's explainable by design, business friendly, consistent metrics, And most importantly, it's scalable, and it can drive innovation with trust. Okay, Stephen, anything to add? We've got a couple more minutes.
First off, this question back there. Hold on, get my steps.
I might be sleeping. Sorry for a dumb question, but which database you connected to populate?
In our demo,
Yeah.
what did we use?
Yeah.
So GraphDB we used as the underlying data graph database.
But in GraphDB, like Neo4j or any other?
Well, so the first tool that we showed was graph.build.
Yeah, that's like a ETL, right? That's
an
not a database, right?
Correct.
Okay.
It's an ETL. It's a model. It's an ontology modeling
Model,
tool and an
yep. Mm-hmm.
And then GraphDB is the underlying graph database.
Okay.
Yeah.
Thanks.
Question up front.
You guys are just messing with me now.
So I'm an ambassador. If anyone else has questions, they take precedent. Okay. What's fascinating is that cost is becoming more of a concern. Memory, GPU, tokens, compute. Inference costs are going down, but context is costly.
Yeah.
And so the cost of processing what you're describing here, I think as organizations go from experimentation to scale, will become more of an issue. And I'm curious how you address that. The more context, the better to a point. What you really want is to be very precise about the inputs that you're going to get from an ontology or another conceptual model to really guide that model to the right answer, plucked from a lot of other stuff that you don't want to process. Maybe you could talk about how you approach cost in your conversations with customers.
Yeah. You were just talking about this earlier, Stephen.
Yeah, so a couple things. I think one is you don't build a knowledge graph just to build it. You have specific use cases and reasons why you're trying to build that. So even though there's a cost associated with it, there's a reason why and an ROI. So in our previous talk, we were talking about ROI and the net application of that. So I think cost has to be a part of it, but you also have to have a clearly defined business use case. And then you build the ontology for every other use case. So you just keep building and building and building, right? So that gives you the ROI right away. The second thing is, I think from the aspect of what poor business decisions do you make because somebody gives you a wrong answer and somebody takes that wrong answer and implements it, building the knowledge graph does not allow you to get a wrong answer. So there's some value in that as well. So when you're looking at ROI, agreed cost, tokens, all that fun stuff, but you also have to look at the business reason and why you're doing it in the first place.
That's fair. Other questions?
Everybody wants a beverage, that's why.
Ready?
So the inputs to respond to your plain language question was the graph that you built in the first step. Is there any layer of information that would be analogous, say, to a skill where you need to provide a little bit more guidance that is at a level above the individual objects or the relationships or their attributes? And do you have a facility for doing that or a mechanism to be able to do that?
That's a great question. The answer is no, I don't think you need that, but use case dependent, it can help, and it may even be the solution in some areas. So in terms of, I've asked the question, can ChatGPT, navigate my ontology, my graph data out of the box? Or do I need to build a skill that understands the W3C standards for what is RDF data and so forth? And the answer is no, you don't. I've actually started to build that skill to see if it helps. So, and the other way to think about it, I think your question says, is the ontology enough, or is maybe there a layer of context? What's the domain? Does the AI understand the domain of the ontology? Can I provide that? And in that regards, I would start to look at this as a skill or a tool, but that skill contains the knowledge base. It contains the ontology to be able to answer questions. So if I built an ontology around, I'll use my use case that around the the data management process, right? What is the knowledge on how I run the business, how I manage data? I can actually create a skill for that. And that skill leverages the ontology, pulls the same answers like we just saw, but not only can it answer those questions, but now I can deploy that skill to my users in their applications, right?
Or agents.
Exactly. Yeah.
And it speaks to the question about efficiency and a large model steering toward.
Yeah, exactly. Yeah. Efficiency in large models, so we can break that down with skills.
Doug Hausman, Ab Initio. Thanks, Matt. Great talk. Just kind of, obviously this is a chat kind of example, right? But you can imagine for big enterprises, right? You start getting into agentic workflows and all of that, where you've got agents leveraging the ontology, leveraging the knowledge graph. That's where, I think the real power will ultimately come. But, at the end of the day, it also needs to be leveraging the knowledge graph needs to ultimately create deterministic code that you're going to actually adopt and put into a product that then brings a person who's a knowledge worker looking at a UI, getting that information. It can't hallucinate. It's got to be tied to deterministic processing, right? And so that's just that next frontier as agentic workflows actually start to get into production. Ultimately, it can't be making this decision and generating a Sparkle query that could potentially not get the right answer. It's got to be grounded in deterministic code in the end, right?
Yeah, what I think I hear you getting at is moving beyond a chat interface and answering ad hoc queries to enabling the agentic workflow and actually delivering those results in situ in the application where agents and other users, they're already coming to that screen. They're already coming to Power BI. They're already coming to the data catalog or the data quality rules engine. And we want that information surfacing where our users are already coming to. Yeah, super important. It's the next step. Anything else? All right.
Awesome.
Thank you all so much. See you at happy hour.
See you.